Welcome to the last video on quadratic equations, and this time we're going to learn everything about the characteristics of the roots we are able to obtain from our quadratic equations. So, the characteristics of the roots of a quadratic equation is determined by the discriminant b squared minus 4ac. Okay, that discriminant, you can find it in your quadratic formula. It's your radicand. Okay, it's the expression under the radical sign, that's b squared minus 4ac. So the conditions is that if this discriminant, if your b squared minus 4ac, once you solve it, gets to be equivalent to 0, that means the roots that we're going to get are real and equal. Okay, let's write that in our notes. So in your formula, in your quadratic formula, that is x equivalent to the negative of b plus or minus the square root of b squared minus 4ac all over 2a. This particular expression here, k, is known as your discriminant. The first condition is, or some references use capital letter D as a symbol for the discriminant. So the guidelines are that if your discriminant, which is b squared minus 4ac, is equivalent to 0, then you get real and equal roots. Okay, let's say, for example, you have x squared minus 2x plus 1 equivalent to 0. In this example, you will have your a be equivalent to 1, b is equivalent to negative 2, and c is equivalent to 1. If we solve for the discriminant, b squared minus 4ac, okay, which is equivalent to your d, or if by substitution, that would be equivalent to negative 2 squared minus 4 times a, which is 1, times c, which is 1 also. That's equivalent to 4 minus 4 becomes 0. So your b squared minus 4ac is 0. Okay, that means this equation will create real and equal roots. So if we're going to factor this, let's try to factor it if we can factor it. Solving for the roots, okay, of x squared minus 2x plus 1 equivalent to 0. Let's try to factor it. So you have x. What are the factors of positive 1 that will create negative 2 as a sum? And that's obviously negative 1 and negative 1. So if you write that, that's x minus 1 quantity squared equal to 0, right? And that gives you two roots which are both equivalent to positive 1. You get x minus 1 equal to 0, therefore x is equivalent to 1. And this is also the solution for the other root, okay, because you have two factors, x minus 1. Thus, your roots are 1 and 1. Right? So if your roots are 1 and 1, they are real and they are equal. Okay? That is, if b squared minus 4ac is 0, that gives you a real and equal roots. Okay? Letter B condition is that if the discriminant, which is b squared minus 4ac, gets to be greater than 0, you'll get roots which are real, still real, but this time they are unequal. Okay? Here, you have real roots, but they have the same value, that's 1. But if your b squared minus 4ac is greater than 0, then you get real roots pa rin, but these roots will be unequal. Let's say, for example, you have x squared minus x minus 2 equivalent to 0. Okay? If we're going to set a is equivalent to 1, b is equivalent to negative 1, and c is equivalent to negative 2, and if we're solving for b squared minus 4ac here, okay, that would be equivalent to 1 squared. Okay, that's 1 squared. That's negative 1, that's b. Negative 1 squared minus 4 times a, which is positive 1, times c, which is negative 2. And this will give us positive 1. Okay, positive 1 plus 8, right? Negative 4 times negative 2 is positive 8. So you get b squared minus 4ac, which is actually equivalent to 9, and therefore, it concludes that b squared minus 4ac is greater than 0 because it is 9. Mas malaki siya sa 0. In that case, it will create real and unequal roots. Real roots but are not equal. So let's try to see if we can factor this. So you have x squared minus x minus 2 equivalent to 0 so that we see if they are real and unequal. So we get there x and x. We have to think of factors of negative 2 that will produce negative 1 as a sum. And that's obviously negative 2 and positive 1, right? Okay, negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So that's correct. And then we equate each of the factor to the right side of the equation, which is 0. And we'll be able to solve x equal to positive 2 as one of the roots. And then we get x equal to negative 1 as the other set of roots. So these roots are real numbers, but they are unequal. Okay, that's your second condition. Your last condition is, if your discriminant, okay, which is b squared minus 4ac, is less than 0, then you will get roots which are imaginary or complex numbers. So these are roots which are not anymore in the real number system. So these are your imaginary roots. And you'll be able to get them if your discriminant is less than 0. That means you get a negative discriminant. Okay. Let's say, for example, we have x squared plus x plus 1 equivalent to 0. In this example, we are going to set a equal to 1 based on the general form. B is also positive 1 and C is also positive 1. So in this case, using your discriminant, the formula for your discriminant, which is b squared minus 4ac, this will be equivalent to, by substitution, 1 squared for b, minus 4 times a is positive 1 and c is positive 1. So we'll get here positive 1 minus 4. You'll get b squared minus 4ac equivalent to negative 3. And this concludes that your discriminant in this equation is actually less than 0 because you get a negative answer. And that will result to an imaginary root or a complex root. So if we're going to try to solve this, try to prove, okay, we have here x squared plus x plus 1 equal to 0. Let's try to factor this and see what would happen. So you get x and x, okay. Okay, so what are the factors of 1 that will produce a sum of 1 as well? Actually, wala, diba? So, instead of that, let's use quadratic formula to solve this problem. So, my quadratic formula is x is equivalent to negative of b plus or minus the square root of b squared minus 4ac all over 2a. So, in that case, I will get x equal to the negative of 1, that's b, plus or minus, I was able to solve b squared minus 4ac, that's negative 3. So, I get the square root of negative 3 for that, all over 2 times a, which is 1. Okay, in that case, I will get x be equivalent to negative 1 plus or minus, that's 3i, right? Okay, negative 3, the square root of negative 3 creates 3i all over 2. And this shows us that the roots will be imaginary because of the presence of the imaginary unit. And thus, you have a complex number as the root of this particular equation. Okay? And we were able to identify that because the discriminant is less than 0. It is negative 3. So, we get imaginary or complex number. And these are the 3 conditions or 3 characteristics of the roots that we can have from your quadratic equation.